Well, all right, we're moving on to arithmetic series. What is an arithmetic series, you ask? It is simply the adding of the terms in an arithmetic sequence. Now, if we only got 2 or 3, 4 terms in a sequence, that's not too bad. We could just rip through it on the calculator. But if we've got a lot of terms in the sequence, we're going to need some help. And you can see on page 668 in your textbook, the key concept block, partial sum of an arithmetic series, gave us 2 formulas, a general formula and an alternate formula. And I might add, you could go to the PowerPoint in your content library, click on the box, key concept box, right click on it, copy it, paste it in your notes in your class notebook, and then you've got it handy for homework, and who knows, it might even let you use it on a test. Well, let's see what we got here. So we've got a series 2, and then it goes to 4 and 6 and 8. And so if we were adding that, it'd be 2 plus 4 plus 6 plus 8, all the way out to 100. Well, that's a lot of terms that I'd have to add together in the calculator, and that seems like that would be too tough a job. So I'm going to use some help. But first, I've got to find all the variables that I need for my partial sum of an arithmetic series formula. And one of those is n. I can see here what a1 is going to be, and I can see an, and I even have been given d in this case. But what I have not been given, what I'm going to need to calculate, is n. Now, you might be pretty slick. You might be able to do it in your head. That's not my purpose. My purpose is to show you how to do it even when it's not so easy as this one actually really is. So let's go. First thing I'm going to do is I'm going to use my find the nth term formula, which is, of course, again, an equals a1 plus n minus 1 d. I'm going to plug and chug what I know. An is 100. A1 is 2 plus n, that's what I'm trying to solve for, 1 times the common difference, which is 2. And we got 100 equals 2. We're going to distribute the 2 to the n minus 1. So now I've got 2n minus 2. And 2 minus 2 is 0, so I'm left here with 100 equals 2n. I'm going to divide 100 by 2, and 50 is equal to n. We solve for n. Now I can plug it into one of the sum formulas. I think first off I'm going to use the alternate. I don't know why. It just seems like I kind of like it. I just want to use it. So let's do this. Let's change colors here. So here is our alternate sum formula. I got Sn equals n over 2 times 2 times a1 plus, and let's say that needs to be a bracket there, plus n minus 1 times the common difference, close the bracket. Let's plug in what we know. So we got Sn equals n, which is 50, over 2, bracket, 2 times a1 in our series, which is 2, 2 times 2, plus, we got n minus 1, so 50 minus 1, and our common difference is 2. Let's close our bracket. And of course, order of operations, we're going to work inside the bracket and the parentheses, so on and so forth. So we got Sn equals 50 over 2, which is actually 25, and over 2, and times 2 times 2 is 4, plus 49 times 2, 50 minus 1 is 49, times 2. Let's close the bracket. Sn equals, I'm going to go ahead and divide 50 by 2, so I got 25. 25. And we got 4, and 2 times 49 is 98. And Sn equals 25 times 102. 4 plus 98, I believe, is 102. And 25 times 102, I've already figured this, so I'm not going to pull out my calculator, but ordinarily I would. And that's going to equal 2,550. So if I were to add all this sequence of numbers, 2 plus 4 plus 6 plus 8 plus 10, then go on and on and on out to 100, I would end up with a total. The sum, partial sum of this arithmetic series is 2,550. How about we do one more? Doesn't matter if you want to or not. We're going to do it. All right, well, once again, we're asked to find the sum of an arithmetic series. And we've been given a little data here. And let's see what we've been given. We've been told that n is equal to 16, and that an is equal to 240, and d is equal to 8. There is something we don't know that we're going to need to know to plug into our sum formula, and that is a1. So let's go. We go an equals a1 plus n minus 1 d. Let's plug in what we know, 240 for an. We're solving for a1 plus 16 minus 1 times 8, 240 equals a1 plus 15 times 8, and 240 equals a1. And 15 times 8, what's 15 times 8? 120. And to find a1, we're going to subtract 120 from both sides. And that's going to leave us with 120. 240 less 120 is going to be 120. And so a1 is 120. Now, what you say? We plug this into our sum formula. This time I'm going to go to the general formula. And that is, let's change colors here. So we got Sn equals, this is the general formula, n times a1 plus a2 divided by 2, parentheses. All right, so here we're solving for Sn, the sum of the arithmetic sequence, or the arithmetic series. And n is 16 times a1 is 120. And an is 240. All of that's over 2. And then we continue on. Sn equals 16 times 360 over 2. Sn equals 16. And 180 divided by, 360 divided by 2 is 180. And let's see, so here we got Sn equals 16 times 180, and 16 times 180 equals 2,880. So Sn equals 2,880. All right, so in this video, we have found the partial sum of an arithmetic series. One example, we used the alternate partial sum of an arithmetic series equation. And in the second slide, we use the general. Usually always having to solve for something else. There's usually one missing term that we have to run through our find the nth term equation in order to plug it into one of the two partial sum of an arithmetic series equations. See you later.